Hi, and welcome to the second part of this two-part Solidworks tutorial to create a toy diner kitchen. As mentioned in part 1, I see a lot of parents these days designing and making their own wooden toy kitchens for their children. So I thought this could be a good tutorial for those who want to plan and design their kitchen in Solidworks before building it. In part 1, we created most of the main kitchen structure. In part 2, we'll be finishing the kitchen part and adding any appearances and decals to the model. There are DXF, part and decal files needed for this tutorial. You will find these in the blog description for download. In addition, I have created this range of toy accessories for the kitchen that are also available to download. I added all of these to the finished design for a final rendering. So continuing on from part 1, select the top of the counter and insert the Toy Diner Counter DXF file. Untick the Importer's reference box here and select Next. Change the DXF dimensions to millimeters and select Finish. Move the sketch entities onto the countertop like this and close the sketch. Sketching onto the countertop, trace over the DXF here with the rectangle to create the griddle base and extrude the sketch by 5mm, untaking merge result. I will keep most extruded features as separate bodies as mentioned in part 1, so unless I say merge the result, untick the merge result box for each boss extrude feature. Next, sketching onto the griddle's top face, right click and select one of the edges of the griddle grate pattern and select the chain. Hold Ctrl and select all of the others and then convert the entities to look like this. Extrude the sketch by 2mm and merge the result to the griddle base extrusion under Feature Scope. Repeat the process for the hobs, selecting all the chains of the sketch while holding Ctrl. Convert the entities and extrude the hobs by 9mm. For the coffee pot stand, trace the outer square sketch and extrude it by 9mm. Sketching on the top of the extrusion, sketch the outer circle and extrude it by 5mm. Then again, sketching on top of that extrusion, trace the inner circle and cut extrude it by 2.5mm. Moving on to the sink, draw back onto the countertop and use the rectangle to trace over the middle rectangle. Cut this straight through the countertop by 12mm. Sketch back onto the counter and trace over the inner rectangle and the middle one again. Extrude this sketch by 77mm to create the inner sink sides. To create the sink bowl's rim, sketch onto the counter again. Select and convert the outer chain of the sink sketch and trace over the inner rectangle and extrude it by 3mm. Merge it to the sink extrusion under selected bodies in the Feature Scope. To close off the bottom of the sink, start a new sketch onto the sink's top face. Trace over the middle rectangle again and go to Extrude. Ensure the dimensions are still on 3mm, then under From, change the option from Sketch Plane to Vertex. Select the end point of the sink extrusion here and merge it to the sink body. For the tap, I need a new plane, so using the right plane, under Reference Geometry, select Plane, then select the midpoint of the sink here for the second plane reference. Sketching onto the new plane, use the centre line to create some guides for the tap placement. Starting from the outer edge, draw a 67mm line inwards. From the end point, draw a line vertically upwards by 70mm. Then using the line again from the end point, hover over until a yellow circle icon appears and the line turns into an arc. Curve the arc over, horizontal to the end of the line with a radius of 35mm. This creates the tap's outline. Use Boss Extrude Thin feature mid-plane by 20mm, and mid-plane for direction 1 at 20mm to create the tap's body. To finish the tap off, fill up the tap's opening here by 2mm. Now, to add the downloaded door hinges, I'm going to bring them in using Insert and Part. Firstly, open up the top door hinge. Select the drawing pin here under Options to drop in multiples of the part. Then click to drop the hinge, placing one near each door, and OK the feature. Hide the side and middle panels of the kitchen to make it easier to make the hinges. Use Move/Copy Bodies to move the parts into position, ensuring Copy is unticked, and ensure you select the hinge with the 2 screws under Bodies to move. Then select the Constraints option here to open the Mate options. Start by mating the under face of the hinge here to the top cutout edge of the oven door, and select Add. This would automatically mate coincident. Then make the left hinge face here to the left face of the door. Select Add to apply it. And finally, select the back face of the hinge front here to the front face of the oven. Select Add and OK the Move feature. The hinge will then be fully snapped into place like this. Repeat the process for the fridge door, ensuring you attach the hinge with the screws to the top of the door. Next, bring in 2 copies of the bottom door hinge in the same way. And mate one onto each of the door panels on the bottom corners. Ensure you apply the 3 mates to each hinge. Once they've been added, bring the other panels back into view and save your part. To open and close the doors in the part, use View, Hide/Show and make the temporary axes visible. Use Move Bodies and select all the components of the hinges attached to the oven's door, the oven door panel, window and handle parts. Select Translate/Rotate and under the Rotate options, select the hinges axis here, the rotation axis to open the door. You can then play with the angle of the open door seen in the feature preview. You could do the same with the fridge door along this hinge axis, and when you want the doors closed, just suppress them in the feature tree. With the kitchen model finished, we're ready to add appearances. Under Solid Bodies, select the backboard parts and the oven door. Then open the appearances using the tab. Even though the kitchen would be wooden, the wood would be coated or painted, so I'm going to use the car spray paint appearance to add colour and a slight reflective finish. Selecting the painted car in white, click into the swatch box here and click into one of the empty swatch boxes. Then select Define Custom Colours, and here I can create a specific colour based on its RGB values. I want to add a specific Pantone, so I can use its RGB values. To create a light grey, input 218 for red, 217 for green and 215 for blue. Then add it to Custom Colours and apply the appearance. As you can see, our specific Pantone colour has been applied. For the dark grey parts, select the bottom panel, the separator panel, the back of the cooking panel, the middle panel, the shelf rails, the cooker handle parts, the poles for holding the sign panel, kitchen side panels, the coffee pot base, and the tap. Go to Edit Appearance and add the painted car in white. Change the swatch colour again, selecting into the next empty swatch box, define custom colours, and change the RGB values to red 99, green 100, and blue 104. Add the custom colour and apply it. The next colour is white. For this, select the fridge door and shelf and apply the painted car appearance in white. Select both door windows and add the glass gloss appearance in clear glass. I chose this over clear plastic as it seems to translate better into Solidworks Visualize when I render. Selecting the oven shelf, the two small front panels and the utensils pegs, edit the appearance to painted car in white. Edit the swatch colour again, selecting a new swatch space. This is useful to do in case you want to use the colour again in the same document. Edit the colour to 153 for red and blue and 152 in green. This creates a medium grey. Next, select all the oven dials, both hobs and the coffee stand top. Apply the painted car spray paint in black. For the turquoise coloured parts, select the countertop, shelf and pegs back panel. Under appearances, add the painted car in white and once again edit the swatch. Select a new custom colours box, define custom colours, type 0 for red, 175 in green and 169 for blue. You don't need to be this specific when you follow the tutorial, you could choose whatever colour you'd like. In the case of the sink, this would be plastic, so I'm applying a medium gloss plastic in light grey. For all the hinge parts and screws, add the chromium plate appearance. Finally, select the kitchen plinth panels, fridge handle parts and the griddle. Apply the car paint appearance in metallic cool grey. With all the appearances added, I can apply the final details using decals created in the vector program. Selecting the front face of the top backboard body, go to the decals icon here and browse for the kitchen back panel. When it opens, under mapping options, change the mapping type to projection so that the decal window becomes visible, and select the fit width and height to selection boxes here. This should fill the part face with the decal. The next decal is for the sign panel. Select the front face, edit decal, and open the diner sign panel decal. Change the mapping settings into projection again and select the fit width and height selection boxes to cover the panel. Repeat the same process for the next two decals, the oven panel here, and finally the fridge door detail. Once the kitchen is finished, you can take it into an assembly like I have and add in all the accessories. Most parts are mated using the coincident mate, but some, like the sausages, are mated tangent to the griddle. The fries part has a visible sketch which can be used to make them concentric to the centre of the pan. I also had to hide the fridge window panel to mate the milk onto the fridge shelf. Once your design is finished, you can render it in Solidworks Visualize. I created a room part for my kitchen to sit in and added it in an assembly, but also to add sunlight to come through the window. This created a realistic room setting for my kitchen. I hope you enjoyed this tutorial. Thanks for watching.